Okie dokie, we're going to get started here on a lesson on solving linear systems by graphing. If we um, if we look, you might not understand some terms here. You know what graphing is, you know what solving is, but what it's a linear system. If we look at this next slide here, you can just look at this. The example of a linear system is going to be, it's basically when we have two equations. When you have two equations there, and what is the solution to that? The solution is going to be the point or points in which the two graphs, the two lines, intersect. And that's that's how we solve a linear system, is by graphing them. Well, there are a few other ways to solve them, but today's lesson is going to be on graphing, and the intersection point will be the solution. Some systems will have no real solutions, no real solutions. Oh, I'm running out of room there. Or if I can do this. Oop. Hey, there we go. No real solutions, and if we think about it, what type of lines will not intersect? Well, if we have a line like this, and we have a line like this, they will not intersect, and what do you call those lines? You call those parallel lines. We also have some system of equations where um, all real solutions will be the answer. And if you pay attention to this, we have the red line graphed. And for the second graph, it's going to be in yellow. And what do you notice? They lie on top of each other because they are the same exact line. So then they have every single point in common. So those are two scenarios. The third scenario is here on the next slide. If you just look at this, you have a yellow line, which is the yellow line is negative x minus 9y equals negative 15. And the green line, which is negative 2x plus y is equal to negative 11. So the solution is where those two lines intersect. And if we look, they're intersecting right here at this point. So the answer there is going to be 1, 2, 3, 4, 5, 6, 1. 6, 1 is the solution to that system of linear equations. So that'll be your answer there. You can take 6, 1, plug it in for x and y, and plug it in for x and y in both equations, and the left side here will equal negative 15, the left side here will equal negative 11, and that's how you can check to make sure your answer is correct. Okay, so let's get started here on graphing. Let's go ahead and graph some of these. You have to use your knowledge on graphing to do this. And so if we look here at these equations, let's work with, let me get the outline out of the way. Let's work with some of these. Let's work with this bottom equation here. I want to work with that. I'm going to change it. You can use it finding intercepts, but I think that if we add 2x to both sides of the equation, y is going to be equal to, those cancel, 2x plus 6. And this is now in slope-intercept form, 2 being the slope and 6 being the y-intercept. So let's go ahead and plot that y-intercept right there. And the slope of 2, that would be 2 over 1, rise 2, run 1, rise 2, run 1. You can make all those points if you want. Let's go ahead and get us a line here. and it looks something like that. Make sure you're using a ruler when you do this. That way your line is straight, because if you need to be using graph paper and a ruler when you do this, and you also need to pay attention to making more points on the graph than probably what you're used to. Now, you don't have to actually put those there, but you have to be able to see those on the graph. And when you graph this, you should see those extra points there, and that way your line is as straight as possible. And when you use a ruler, make sure you're going through those points, because sometimes your ruler gets off just a little bit. And then when we are trying to solve a system of equations like this, you're going to come up with some wrong answers here. Let's go ahead and look here at the top equation. I'm going to bring it down here. So we have x plus 2 times 0 is equal to 3. I'm finding intercepts. So x is equal to 3. And remember, y was equal to 0. So that's 3, 0. If x is equal to 0, y is going to be, let's see, those cancel. Divide each side by 2. So y is 3 halves. So x was 0, y is 3 halves. And so there's our intercepts. So plotting the x-intercept of 3, 0. 1, 2, 3. Plotting the y-intercept of 3 halves. We know that's 1 1/2. Somewhere about here. Okay. I'm not a big fan of those ones there that are right in between those marks. Look up here. X plus 2y is equal to 3. Let's subtract x from both sides. So we have 2y is equal to negative x plus 3, and divide by 2, divide by 2, divide everything by 2. So y is equal to negative 1x over 2, which that slope would be down 1, yeah, down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2, up 1 to the left 2. And I did that because these points that I just plotted are right in between those grid lines exactly. And if we look, that y-intercept right there was, I mean, we're close to 1.5, but we're not exact there. But with these points that I just put on there, we are exact because it's crossing the grid lines exactly. So let's go and plot this line here. And as I'm doing that, I was noticing that it was crossing at the slope that I needed. It was crossing all those points. Even though I didn't have those points on there, I was looking to make sure it was crossing at those points. Let me go ahead and get rid of all these points here so we can see our two lines then. So we have these two lines. Now we need to know where they are intersecting. If we look at the orange line is off just a little bit. If we look right up here, it is not crossing exactly at 6. So I'm going to slide that over just a little bit. Sometimes you get these to be exact, and sometimes you're off a little bit. So I want to look there. Your lines should probably be real close. All right, if I'm looking here, the answer here, it's not going to be an exact solution and an exact answer. Like with this one here in the previous slide, 6-1. This one here is a little tougher to calculate. I think I have a few examples on the next few slides that are easier. But let's look here. Let's see. Find the x value. The x value. Here's negative 1. and we know it's past a half, so let's see, here's a half, maybe negative 1.75. Is that what you're thinking? Negative 1.75. And what's the y value going to be? The y value right there. What number would that be? Well, 1, 2, it looks like it's a little bit below a half, so looks like it's maybe above a quarter. So what about 2.3? Like 2.3 repeating? And so that'll be the solution that we will say is the solution to the system of linear inequalities. Now, when we have decimals like this, probably graphing isn't the best way to find the solution here, but our directions tell us to graph to find the solution. The next few sections, we're going to learn different ways to find the solution that are going to be more exact, that are going to give us an exact answer here. All right. If we look there, there's going to be our solution. Let's move on to the next page here. Let's go ahead and get these lines out of the way. How do you want to let's change these to slope-intercept form, subtracting 3x from both sides. And this one up here, oh, let's see, what do we have? 2x minus y is equal to 1. We can subtract 2x, subtract 2x. So don't forget your negative sign. Negative y is equal to negative 2x, and it's a positive 1. And then we divide everything by negative 1. So our new equation y equals 2x minus 1. Negative divided by negative will give you a positive 2x, and a positive divided by a negative will give you a negative 1. So let's go ahead and graph these. Let's graph this one in red. Y-intercept's at 9. 2, 3, 4, 5, 6, 7, 8, 9. And slope is down 3 to the right 1. Down 3 to the right 1. Let's go ahead and get us a line on there. And I was looking to make sure that it did cross here, here, and here were the additional points. All right, let's graph this one here. Y equals 2x minus 1. Negative 1 is the y-intercept. Slope of 2 means you go up 2 to the right 1, up 2 to the right 1, and right there is where they're going to intersect. So that one works out easy for us. That one's a lot easier to figure out than the last one we did. And if we look there, that will be our solution right there in green. So what is the ordered pair? 1, 2 places to the right, 1, 2, 3 places up. So the solution is 2, 3. 2, 3. So this next one, I want you to go ahead and graph those two. Go ahead and graph those two and see if you can come up with the solution. Pause the video and then play it and make sure that your answer matches mine. And then we have a few more examples to do after that. a few special cases. So go ahead and pause the video, work it out. We're going to work with the bottom equation first. I'm going to subtract 2x from both sides, so I'm left with y is equal to negative 2x minus 3, because those canceled out. Let me go ahead and plot that one real quick. Negative 3 is the y-intercept. The slope is negative 2 over 1. Means down 2 to the right 1. I could have also, from the y-intercept, went up 2 and to the left 1. Go ahead and get our line. Yeah, that didn't work. Let's go ahead and get this line on there. Yep, that looks good. Okay, now let's go ahead and work with the top one. The top one right here. 6x minus 3y is equal to negative 15. Subtract 6x from both sides. Those cancel. I'm left with negative 3y. Do not forget the sign in front of the 3 is negative, so it should come down with it. Negative 6x and negative 15. So we have negative 6x minus 15. And in order to get y by itself, divide both sides by 3. So y is equal to negative 6 divided by negative 3 makes a positive 2x, and negative 15 divided by negative 3 makes a positive 5. Let's go ahead and graph this now. Y-intercept's at 5. 1, 2, 3, 4, 5. And the slope is 2 over 1. Let's go ahead and get those points plotted. And I'm checking to make sure that it's going through all of the points that has a slope of 2 over 1. And just because from our y-intercept here we went up 2 and to the right 1, that's also down 2 and to the left 1, down 2 and to the left 1. And right there is the point of intersection. So what's the answer? From the origin, we go left 1, 2. So left 2 means negative 2. And how many up? Up 1. And so there's our answer. Negative 2, 1. These ones here are already in slope-intercept form for you. So let's go ahead and you go ahead and try and graph these, find the solution, and then check your answer. We'll graph the top one here, negative 1. Slope is 2 over 1. 2 over 1. And let me go ahead and get this line in here. And we'll extend it. You should always extend them in both directions because you never know where this second one is going to cross it at. So let's say y-intercept is positive 1, and the slope is the 1, which is 1 over 1. So 1 over 1, 1 over 1, and there's our answer. Let's go ahead and graph our line. There we go. And if we look, what's the solution there? Where are those two lines crossing? Let's see, the x from the origin. 1, 2 to the right. 1, 2, 3 up. 2, 3 is the solution there. Solution 2, 3 is that point where they're crossing. And the last two examples here, let's have you go ahead and try those fairly quickly. And I think these are the special cases. Nope, maybe not. We'll come to those. At some point, we'll come to them. Go ahead and graph these two. Check your solution. Pause the video, too. This one right here, y-intercept, is positive 2. So that means we go positive 2 and plot the point. The slope is 1/2, so that means we rise 1 and we run 2. Rise 1 and run 2. Let's go ahead and plot our line. And if we look there, I notice it's off just a little bit. So I'm going to make it a point to get that down to where it needs to go. And I think that's better, right? Yes. Much better, much better. There's the point, there's the point, there's the other point, and there's, you notice those ones are all one now. Okay, now the second one here, second equation, negative x plus 5, y-intercept of 5. 1, 2, 3, 4. Plot your point. Negative x, what's that mean? Well, it means negative 1, right? Negative 1x, and then the slope is negative 1 over 1. Remember, the negative sign only goes with either the top number or it goes with the bottom number. It does not go with both of them, because if it is with both of them, then that's negative 1 over negative 1, which is equal to a positive 1. And this is not what we have up here in this equation. All right, so negative 1 over 1 means down 1 to the right 1, down 1 to the right 1, and that's where they're crossing. And notice that I'm crossing, down 1 to the right 1, right there, right there, right there, right there. I'm crossing the grid lines exactly, and even above the y-intercept, I'm exactly crossing the grid lines. Pay attention, because this one right here looks like it's not crossing. It is crossing. The white intercepts, or I'm sorry, the white axes are laying, the x-axis is laying above where it's really supposed to be, if you can kind of see that closely. All right, the solution here. The solution is where these 2 points are crossing. They're crossing right here. What is that one? 1, 2. 1, 2, 3. We've had a lot of solutions where x is 2. It just happened to be that way with the equations I've been working with. They won't always be 2. The x value won't always be 2. Just kind of giving you a heads up there. And the last one that we're going to work with, let's see you go ahead and do this one. Check your solution. Y equals x minus 2 is the first one we're going to do. Slope of 1, y-intercept is negative 2. Negative 2, make sure you're paying attention to the signs in front of the numbers. So slope of 1, that means slope of 1 is 1 over 1, right? Up 1 to the right 1, up 1 to the right 1. And that one should be a fairly easy one for you to see. How's that look? I think it looks okay. And now let's look at the bottom one. Y-intercept here, +1. So that goes to be +1 on your graph. And the slope is -2, which is -2/1. So -2/1 means we go down 2, 1, 2, to the right 1. That's going to be our answer. Down 2, to the right 1. Down 2, and to the right 1. And let me get rid of some of these dots here for you. So where those two lines intersecting, those two lines are intersecting at that point right there. And what is that point? 1 to the right and 1 down. Remember, it's down, so it's -1. 1, -1 is the solution there. Basically, when you solve linear systems by graphing, it's nothing new. It's just graphing two lines and finding the point where they intersect. It's just, I guess that would be the new part to you, is just finding out where they intersect. So, all right, well, that's all we have for this video here on solving linear systems by graphing. We will see you next time.